Okay, the automotive electronic system. So the present system is, for example, present system is nothing but mechanically occupied systems. So when you look into the automotive engineering or automotive systems, 20 to 30 years back, so only there was a mechanical component was present in the total automotive vehicles. The year by year the technology was grown. Gradually the electrical and electronics component was involved in the automotive systems as well as so this main the motto of these electronic components and electrical components is to simplify the works as well as it is going to increase the sensitivity in each and everywhere what are the components is present in the automotive systems, because the when electronics is going to implemented, so instantly we will get the feedback as well as we can able to comment the systems which is connected directly to the electronics. So based on that it will automatically works, so we don't want to check on the regular basis because of most of the electronic components, because we have using electronic control unit and control module in all automotive vehicles. So that system is very much simplified as well as that system which simplified most of the works. The efficiency of the automotive electronics automotive system also increased when we use all electrical and electronic components in automobile or automotive vehicles. Okay, because we can easily simplify the work, and fault finding is also simplified. We can then and there we can easily identify all the problems according to the automotive vehicles, as well as we got lot of informations and details regarding the vehicle. Okay, and so many automatic automation was done in the most of the cars, because nowadays the most of the vehicles are electrical vehicles. Okay, most of the cars are equipped with electrical cars. Most of the government is also worldwide planning to implement electric cars to reduce the pollutions. Okay, pollution is one of the major issue and major problem to each and every country, not only in India, because most of the country pollution is the major issue. But India, we need to look into that because pollution is definitely very major problem, because here we there are huge populations in India, so that populations is going to produce lot of pollutions and emissions to the environment. Yes, definitely it may happen, because why I am telling this is because each and every, you can assume there may be 100 crores of peoples, because there may be 50 crores of peoples may have vehicles. In the house there are two or three vehicles are there, including car, two-wheeler, etc. So there are a lot of pollutions is created every day, every minute, every single minute. The pollution is going to spread out over the atmosphere. So that is going to make huge impact to the society, because there are a lot of problems is occurs due to that pollution emissions. So the human beings also affected, as well as ozone layers also affected, and lot of diseases is also comes because of the high emissions. So in order to reduce and in order to monitor these things only, so the European emission standard was framed, and the year by year they have reduced the emission ranges. But in India now we are having Bharat stage 6. When Bharat says 6, so we are using a catalytic converter in all the vehicle irrespective of wheels, two wheelers or three wheelers or four wheelers, so to reduce the emission rates. Because this in automotive systems, you just look into this here, present vehicles only, the driver is going to carefully drive the vehicles, and he needs to have more attention when he is going to drive the vehicles. And the second system, the second generation system is going to change like automated driving. The driver don't no need to uh, use the levers like clutch levers frequently, because it is Okay, the drivers don't need to, guys, don't enter during the presentation because it is going to make a lot of disturbances fun. Okay, the main disciplines in automotive engineers are the safety engineering. So the safety is one of the major important key parameters in automotive vehicles when they are going to manufacturing, or when they are going to purchase any kind of, when people are going to purchase any kind of vehicles. So definitely we need to look into the safety system. Safety is one of the very much important. The safety engineering is also plays major role in this discipline. And the next is the fuel economy and emissions. The fuel economy and emissions is also one of the major important point in the automotive vehicles, because fuel economy is expected by each and every person, those who are going to purchase any kind of vehicles. As well as emissions is directly related to the society, it is related to the atmosphere. So this is also one of the considerable, very much considerable points. Next is vehicle dynamics. When you are going to driving the vehicles, the way about the vehicle stability, steering, and when you are going to do a cornering or whatever it is. So this is we need to take in. And next is vehicle electronics. The vehicle electronics, there are so many components are present in this vehicle electronics. Okay, there are so many components maybe present in vehicle electronics. Okay, vehicle electronics performance and shift quality, durability, corrosion engineering, package ergonomics engineering. These are all the several disciplines in automotive vehicle and electronic systems. All these systems. So these are all the important area in the all automotive vehicles: safety engineering, fuel economy and emissions, vehicle dynamics, vehicle electronics, performance, shift quality, durability, corrosion engineering, package ergonomics engineering. These are all the important parameters. Next is safety engineering. So in this safety engineering, so when people are going to purchase any kind of cars or bikes or whatever it is, so definitely they will look into the build quality of the any kind of vehicles what they are going to purchase. The safety aspects, definitely each and every person is definitely going to look into that, because safety is very much important. So in this safety engineering, the assessment of various crash scenarios and their impact on the vehicle occupants is going to be considered, and as well as this is going to be tested before release of the vehicles, because you can able to see or observe it the many kind of reports, because whenever there are new vehicles are launching, so before launching, it's definitely the company is involved that vehicle into so many tests. So the so many tests they conducted the vehicle before launching any kind of vehicles. In that they will conduct all kind of tests as including the safety aspects. The crash test also going to conducted based on the crash test. Crash tests in India and globally they are going to conduct. NCAP is going to conduct the crash test. So they will give some rating after conducting the test. The star rating 1, 2, 3, 0, 4, 5, like that. So 5 star car star rating is one of the very much build quality car. So we can easily we should purchase these kind of cars, because when you are going to look into the safety aspects, that car may have airbags in 4 sides or 6 sides, including the passengers as well as drivers, co-drivers, etc. And the build quality of the car also very good. And requirements include seat belt and airbag functionality, front and side impact testing. So this is going to be tested, and full vehicle crashes. So, so everything is going to be tested in safety engineering. The safety engineering main purpose is to protect the passengers, drivers, or who are all going to uh, present in the vehicle. So definitely they should be protected, and the vehicle should have more build quality, as well as the vehicle should have more resistance while it is going to be collided. So definitely we should be look into that. So the requirements of the safety engineering is the seat belt and airbag functionality is very much essential. And next is front and side impact testing, and full vehicle crashes. Everything is going to be taken into the account when vehicle is going to be launched. And next is assessments are done with various methods and tools. One is computer crash simulation as well as crash test dummies. So these are all the different categories the vehicle is going to be tested in safety engineering. So they will consider all these points also. And next is fuel economy and emissions. So it is a measured fuel efficiency of the vehicles in miles per gallon or liters per 100 kilometers. So these are all the fuel economy is going to be tested based on this. The emission testing is also going to be have some based on the emissions which is come out when at the end of the compression stroke. Definitely we will have the emissions where the emissions is going to be vary based on the petrol and the diesel. So the general emissions testing, the measurements of the vehicle emissions are hydrocarbons, so this is shortly called as HC, and nitrogen oxides NOx, and carbon monoxide, it is CO, and carbon monoxide CO2. And next is evaporative emissions. If we have a diesel engines, definitely we will have a smoke and a particulate matter. So everything is going to be present in diesel fuel. Next is in vehicle dynamics. So it is a vehicle's response of the following attributes. So how the vehicle is going to be response when you are going to drive the vehicle on the roadsides, during the ride, handling and steering, braking, comfort and traction. Okay, everything is going to be comes under the vehicle dynamics. Next is the design of the chassis system, the suspension, how the suspension performs, whether it absorbs all kind of shocks on the roadsides. And next is steering, whether it is steering is very much is easy, and it is very much friendly to move from left and right directions or desired directions what driver wants. Next is braking efficiency, whether it is very good or not. And next is structure. Based on the structure is also another important thing or important factor when we are going to conduct a crash test. And next is wheels and tires and traction control. Next is dynamics engineer to deliver the vehicle dynamics qualities desired. Okay, so these are all the uh, categories is going to followed by the dynamics engineers. So they should taken care all these points of the automotive vehicles. And next is vehicle electronics. So the vehicle electronics is going to play a major role, and it is going to uh, play major parts are assembled in the automotive vehicles. Okay, the automotive electronics is an increasingly important aspect of automotive engineering. It is responsible for operational controls like throttle, brake, and steering controls, as well as comfort and convenience system, and infotainment and lighting system. Okay, these are all the responsible for operational controls of vehicle electronics present in the automotive engineering, automotive vehicles, and it would not be possible for automobiles to meet modern safety and fuel economy requirements without electronic controls, so that everyone is going to be prefer this electronic control system. And as well as this is not, they said that this is not possible for automobiles to meet modern safety and fuel economy requirements without having this electronic control systems. And next is performance. Performance is measurable and testable value of a vehicle's ability to perform in various conditions. For example, 0 to 60, how much time it is going to take, and how quickly the car or vehicle or bike is going to move when we are going to accelerate it. How quickly a car can accelerate, for example. So they said that standing start 1 by 4 mile elapsed time, that is 0 to 60 miles per hour, etc. Next is the generate without losing grip, recorded lap times, and cornering speed, and brake fade, etc. Okay, these are all the performance. And performance can also reflect the amount of control in inclement weather. So when you are going to drive your vehicle in a very cold climate, in that climate there may be a snow or ice or rain or whatever it is. When you are going to drive your vehicle, for example, in the hill stations like Ooty, Kodaikanal, or Jammu Kashmir, or uh, Kulumanali, or what, wherever you are going to drive your vehicles, so that time also you have to look into the vehicle performance. So these are all the things they will keep in their mind in R&D department of automotive manufacturing company, and they will design their vehicle according to these different things. So based on that only they will design, they will consider all these factors. Okay, because the customer is going to uh, travel at anywhere, not like specified places, so they can drive their own vehicle to at anywhere. And they may face lot of climate issues when they are going such a climate. So what about the vehicle performance? So these are also going to tested by the automotive vehicle manufacturers before they launch the vehicle. Okay. Okay, there are some trends in automotive system. So this is, we know very well, car technology in 1981. So we have used only the mechanical system of cars. So during that year there was no electronic, there was no electronic evolution was happened in 1980 1891. So we have only the mechanical system and mechanical components. And during that time the traffic was also very low, as well as there are only less number of vehicle was driven in the roadside, because during that time only the vehicle was innovated by some of the persons. And driver skills is very high, technical skills is required during that time. And 1920, so gradually they have invented the pneumatic system and hydraulic system. And at that time also the traffic also very low, high technical skills and low driving skills, and is a record. 1950s, so the electrical system is going to gradually enter into automotive vehicles. And it is also increasing the driving skills, the traffic also increasing, and good technical skills also required to operate the vehicles. In 1980s, so electronic was involved, and optronic system was involved. The congestion is going to start, as well as the driver skill is low, technical skill is enough, and high driving skill is required. And 2010, so the nano electronics and the biotronic system is also going to enter into the automotive vehicles. They even this time also the traffic also congested and optimization is going to start. So very low technical skills is enough, and decreasing driving skills in 2010. And 2040 definitely. So what we are going to expect, and what automotive industry is also going to looking into that robotics and nanotechnology. So this traffic is also maximum, and it is going to optimize. And there was no driving skills. The important point is here is no technical skill is required, and no driving skill, because most of the automotive industries are planning to introduce the autonomous vehicles. But I don't know how it is going to effectively implemented in the India, because India is most populated country in the world, next to China. So, but in most of the foreign countries, definitely in 2040, and after that they will have some autonomous cars. They just go to simply enter into the car, and they will just share their locations. The car will carry all those things, driving skills, everything is going to taken care by the car, because that kind of robotics and autonomous systems, the technology is going to implemented in that car. That car name is also called as autonomous vehicle. So it is going to, it is act like robo. The next is automotive electronics, the introduction of electronics in non critical application. So the driver information and entertainment, for example, radio, comfort and convenience. For example, electrical windows, wiper, washer, seat heating, and central locking, interior light control. So there are most of the places the automotive electronics is going to gradually entered, and the low intelligence electronic systems and micro communication between systems, push button control, and no impact on engine performance and no impact on driving and driver skills when you are, because of this system. Next is phase two, the electronic support critical applications or engine optimizations, for example, efficiency improvement, and the pollution is also going to be controlled, as well as active and passive safety, for example, ABS, ESP, and airbags, tire pressure, and xenon lamps. As you know very well, ABS, anti-lock braking system, as well as airbag system. And driver information and entertainment is also going to be monitored of this electronic system. Example, radio, CD, GPS, parking radar, service warning. So everything is going to be uh, displayed because of using this electronic controlled system. Here we are like we are using a mini computer in our car. So we are going to store a program. We have microprocessor or microcontroller, and latest cars are equipped with microprocessor. So it is going to taken care of all the functions of sensors and actuators. So it is namely, it is called as EC, electronic control unit or control module. Okay, the comfort and convenience and security. So everything is going to be taken care uh, of the electronic systems, airco and cruise control, keyless entry and transponders. And increasingly complex and intelligent electronic system is going to happen in every year by year. The communication between electronic systems within the car, and full control of engine performance, and no control of driving and driver skills, and but reactive correction of driver errors. Electronics impact remain within the car. And next phase three. So what are the various things is going to come under the phase three means electronic control, critical applications like full engine control, example start stop cycles, hybrid vehicles. And next is active and passive safety, example X by wire, anti collision radar, dead angle radar, and driver information and entertainment, traffic condition warning, weather and road conditions. Everything is going to be entered in the car, so driver can easily see each and everything. Comfort and convenience. Very little intelligent, robust electronics, communication between internal and external system, information exchange with the traffic network, full control of engine performance, control of driving and driving skills, proactive prevention of dangerous situations inside and around the car, full control of car and the immediate surroundings is going to be observed, and these are all going to be monitored in the phase 3 of electronic system. And phase 4, fully automatic driver. So this is first generation. It is like first generation car and the fully automatic driver. So the traffic networks takes control of the macro movements of the car. And next thing is automatic driver executes control of the car and immediate surroundings, lower and physical layers. And here it is called as Adam. Adam is nothing but automatic driver for automobile and or EV, elegant vehicle automate. So here the driver has become the passenger for the complete or at least for most of the journey, and driver might still be necessary if. And Adam becomes an anarchistic driver, and madman, or EVA becomes engaged vehicle anarchist. So these are all the phase 4 category of the vehicle. And where do we find electronics in a car? You just look into these pictures, you can easily identify there are how many electronic components are involved in the car. You can able to easily observe it here when you just look into the here. So the uh, you just look into these pictures. So there are so many electronics items are involved in and around of the cars. So you can easily able to look into here. So the automated control is also electronic entertainment head-up displays, electronic dashboard controller or electronics light failure control, information navigation, and come to the engine categories. Injection control is going to taken care by electronic, as well as injection monitor, oil level sensing, airflow, throttle, valve control, as well as headlight position control, power control, failure direction, and e-gas is also going to be detected. And tire pressure also nowadays most of the cars is going to monitor by electronic device, as well as gear position is also going to be monitored with the help of electronics, and airbag sensing and control also going to monitor by the electronics. And auto toll payment, yes, now you know very well about the fast tag system. So these are all the these also controlled by the electronic system. Auto toll payment, just you are going to stick that fast track sticker on your card, so then you have to recharge it. Definitely the money will be automatically deducted, you don't want to pay it manually. So there are a lot of advantages are there in auto electronically controlled cars. Interior lighting system, rain sensor. So there are so many plenty components are present, and there are so many components are controlled by the electronic system. And power window sensor, LED backlight, backup sensing, keyless entry, central locking, suspension control, seat control, position, airbag sensing and control. There are so many parts are involved. There are so many electronic components are present, and so many components are monitored by the electronic control unit and control module. Audio வருதாப்பா?
No, sir. Sir, வரலைங்க.
No, sir.
வரலையா? ஆடியோ வரலையா? வருதா வரலையா?
No, sir, no, sir.
என்னப்பா?
வரல சார்.
ஓகே ஓகே. Okay, I think there may be some problem in audio. So I will show you some videos in next class. Okay. Next is vehicle networks. So we need to connect the each and every components is present in the vehicles like sensors and actuators, which is present in all automotive vehicles, so that we are having some vehicle networks. So in that vehicle network, so there may be some transformation. The information is going to be communicated. It is going to transfer from one place to another place, so that we are having some connectivity throughout the network. Because of the networks, we will have the connectivity of the sensors and actuators as well as ECU. So in vehicle networks, which is going to connect the vehicle's electronic equipments, as I said, sensors and actuators and other etc. components. Next, which is facilitate the sharing of information and resources among the distributed applications, as well as these control and communications networks are based on serial protocols, as well as replacing wire harnesses within vehicle networks. Next, which is going to change the point to point wiring of centralized ECUs to the in vehicle network of distributed ECUs. In vehicle networks, the main aims of in vehicle network is open standard, and it should be easy to use, as well as cost reduction, and it should have some improved quality. And the main benefits of the vehicle network is more reliable of all the cars. And next is more functionality at lower price, and standardization of interfaces and components, as well as faster introduction of new technologies and functional extendability. Okay, these are all the important benefits when you are going to using the vehicle networks in your cars. Next, introduction, the decreasing wire harness weight and complexity, and electronic control unit ECU are shrinking and ending are directly applied to actuators as well as sensors. So introduction, modern automobile networks, like so we're using a different buses. So the buses is going to be transmit the data from one place to another place, or one parts to other parts. So what data or what information is going to pass through the EC, that is going to be sent to the sensor, when sensor is going to receiving the signals and it is going to transmit it to the ECU. When ECU wants to give some commands, means that command is going to be transmitted to the actuators through these buses. Okay, so these are all the different types of buses we are using in modern automobiles network. And so you just look into this, speed is very high, the D2B speed is very high, and 5 megabyte per seconds, and electrical or optical mainly for digital audio we are using this D2B. So this next is most, and this is transmitted data 22 megabyte per second, audio and video and control. The speed is also very high, and origin also auto. Next is flux ray and byte flight and TTP and Bluetooth, CAN and J1850 and LIN. So these are all the different modern automobiles networks. So it is shortly called as buses. Right side you can see the speed of the buses and origin. In olden days, we used a CAN network to transmit the data, but now so there are a lot of technologies and a lot of high-speed data transferring technologies came into the automotive systems to simplify the works and the speed of the process of the data delivery from one place to another place. Next is D2B, domestic data bus. This is shortly called as domestic data bus, and this is going to developed by the Marchusta and Philips. They jointly developed this, and it is promoted in the year of 1992. And domestic data bus was designed for audio and video communications as well as computer peripherals, as well as all automotive media applications. And the D2B is to Mercedes-Benz S-Class vehicles, uses this D2B optical bus network to the car audio as well as autopilot and CD systems. And this the tele-aid connection, cellular phone, and lingotronic voice recognition application also they are using this domestic data bus. Next is most, it is called as media oriented system transport. It was initiated in the year of 1997, and this is also supports both time triggered and event triggered traffic with a predictable frame transmission at speed of 20 megabytes per second. And this is using plastic optic fiber as communication medium. This is very much faster on. And this the interconnection of the telematics and infotainments such as video displays, GPS navigation system, and active speaker and digital radio. Everything is going to be connected with help of this most. More than 50 firms, including Audi, BMW, Daimler, Chrysler, Baker Automotive, and OSIS Silicon System, developed the protocol under the most cooperative. Next is TTP, Time Triggered Protocol, and this is also developed in the year of 1998. It is a pure time triggered TDMA protocol, and these frames are sent at speed of 5 to 25 megabytes per second, depending on the physical medium. And this is designed for real-time distributed system that are hard and fault tolerant, and it is going on to reach speeds of 1 gigabytes per second using an Ethernet-based star architecture. Next is FluxRay. FluxRay is a fault-tolerant protocol designed for high data rate, advanced control applications such as XY wire system, as well as this provides both time triggered and event triggered message transmission. Messages sent at 10 Mbps. Both electrical and optical solutions are adopted for the physical layer. So in this, the ECUs are interconnected using either a passive bus technology or an ACT star topology. So like this, byte flight and Bluetooth and controller area network CAN and local interconnect network LIN are used. You just see here the incremental cost per node to speed byte per second. At presently, olden days we have used this CAN and LIN, and now most of the high costly vehicles are using this D2B most and optic bus and TTB. So these are all the things they are using in our latest vehicles because the technology was growing year by year. So I think at a time